All right, we are moving on to 2.2. Again, if you had any questions on that 2.1a, just let me know. If there's a better way that you think that we could do this, shoot me an email. Kind of open for ideas. Hopefully, you're getting the same instruction as we do in class, kind of the same information, but just let me know. So moving on to subsets. So last time we talked about sets. Sets were just a collection, and then there was items in each set, right? And there was some description, whether it was kind of a set of numbers or a set of months, whatever that is. Now we're moving on to subsets. So a subset is a set of a set such that all of its elements are included in the bigger set. So we have this bigger set called the universal set. Sometimes it'll be like all the natural numbers. Sometimes it'll be like the numbers 1 through 10. Something like that, but they'll tell you. And then that's represented. So a subset is represented by a small c, something like this, and then a line underneath it. That's the subset. And when a smaller set is not a subset, you have that same symbol just with a vertical line through it, kind of like that fancy E, how the fancy E had the vertical line through it when it was like X is not in the set, right? Couple vocab terms or notations that we'll see. This 0 with a line through it represents an empty set. We'll get into that later, but an empty set is a set with no objects, and you can either see that as this 0 with a line through it or just two brackets with nothing in between, right? And then this U represents the universal set. That's that big set we talked about right at the start. First example, we have this set 3, 5, and 7, and we are wondering if 3, 5, and 7 is a subset of the bigger set, the universal set of 3, 4, 5, 6, and 7. So the only thing we have to ask ourselves is 3, 5, and 7 in the smaller set also in the bigger set? Can we find 3, 5, and 7 in the bigger set? Yep. So this set is a subset of the bigger set. The universal set is a subset. Moving on to number 2, same idea. Is the smaller set a subset of the universal set? Are 3, 5, and 7 in this set on the right? Well, there's 3, there's 5, but we're missing a 7, so it is not a subset. Hopefully this makes sense. Here's a 0 with a line through it. What's that mean? It's talking about an empty set. Well, an empty set is always a subset of any set. We'll kind of get into that later with proper subsets and improper subsets. But is there always nothing in something? Yes, it's kind of like the air in the room. Even if it's an empty room, there's still air in it. The air would be a subset of the room. The empty set would be a subset of this set of 1, 2, and 3. Just kind of a different way of thinking. So if you have questions, again, let me know. Here we're going to move on. Try to fill those in by yourself. But here we have list all the subsets of the set A, B, and C. 2 ways to kind of think about this. We can list them all out, so we know that the empty set is always going to be a subset of a set. And then there's also a set of A, B, C, A and B, A and C, B and C, and then all 3 A, B, and C. How many subsets did we just find out of a set of 3? Well, there's only 3 letters up here. There's only 3 items in the set, but we had 8 subsets that we could create out of it. All sorts of combinations. How do we know that 8 is the correct number of subsets? Well, we're going to take the cardinal number of this set. So cardinal number is how many items are in the set, right? 1, 2, and 3. And then we're going to take 2 to that power. So 2 to the 3rd power because we had 3 items in the set. 2 to the 3rd power is 2 times 2 times 2, which is 8. So there should be 8 subsets of this set of 3. How many did we find? 1, 2, 3, 4, 5, 6, 7, 8. Checks out. The formula to find out the number of subsets is just 2 to the n. That n just represents how many items are in this set. So our cardinal number, our n, would be 1, 2, 3, right? Now, proper subsets are a little different than normal subsets. Subsets include all of these, right? Proper subsets, you cannot include the whole set. They think that the set cannot be equal to the original set, right? So all the combinations are the same. Only thing we're missing is A, B, and C. Now, what's the formula for that, right? It's going to be the same thing as up here, but if we had 7 subsets down here, we're just subtracting 1. So how many items are in the set? What's its cardinality? 3, A, B, and C. That's 3 items. So we're going to take 2 to the 3rd and then just subtract 1. That's how you find a proper subset as opposed to just a normal subset. Kind of talked about this earlier at the top. What's that big set called? It's just the universal set. In this example, we call it U. Before, you've seen it represented as like S for set, or S equals 1, 2, 3, 4. Here we're just calling the universal set U for the universal set 1, 2, 3, and 4. So last vocab word, we have the complement of a set. The complement is just the opposite, right? Kind of yin and yang. So if they're asking for the complement of the subset 1 and 2, what's the opposite of 1 and 2? Here in the universal set, if we take away 1 and 2, what's left over? 3 and 4. So the complement of 1, 2 would be 3, 4. What would be the complement of 1, 3? 2, 4. Kind of like that. There's 2.2. We got a quiz coming up. We'll review when we come back. But if you guys have any questions on the homework, there's help buttons. You can email me. You can email other students in our class. But hopefully this is working pretty smooth. And just let me know. Have a good weekend.